Hello Year 10 and welcome to today's lesson on pyramids. Please pause the video as you write the title and the date. Right, brilliant. I would like to have a go at the do now task. It's a chapter 14 recap, so something we did when we were at school together, where we looked at finding the surface area of prisms and cuboids. We should know the surface area means we're trying to find the area of all those sides, all of those faces that we could touch. And here are the important formulae you need for finding the area of a square or a rectangle, and here for a triangle. Please pause the video as you have a go at these questions. Right, good, let's fly through some answers. So you should have 148 centimetres squared, 228 centimetres squared and 416 centimetres squared. Right, your success criteria today. So bronze, to be able to calculate the volume of a pyramid. Silver, to be able to calculate the surface area of a pyramid. And then gold is to be able to apply knowledge to questions involving compound shapes. And here we've got two terms you should be familiar with from previous chapters. So volume, we should know, means how much space something takes up. And then surface areas, we've also said from the do now task, is all the sides you can touch. So if you think about the dice, the volume is how much space the dice takes up, and the surface area is those 6 faces you can touch. What is actually the area of all of them combined? But today we're looking at pyramids. So we should know a pyramid is a 3D shape. We should have knowledge of this already. Think about the pyramids of Egypt. That's exactly what we're talking about. And it has a base from which triangular faces rise to a common vertex. We should know that really means corner, and it's called the apex because it's always the highest point of the pyramid. Now, the base can be any polygon, so any shape, but usually it's a triangle or a square, and that's predominantly what we'll look at today. And here is an example. Now, the important thing to notice is the height here always meets at a right angle from the apex, which is the highest point of the pyramid, to the base. So it could be slightly different. You could have the height outside the shape here, but we've seen things like that before when looking at triangles, so it's not too unusual. And here is the formula to find the volume of a pyramid. So please just write this down in your exercise book, pause the video as you do this. Very good. We're going to look at an example together. I'll go through the example and then I'd like you to pause the video and copy it down. So we're going to find the volume of this pyramid, how much space it takes up. Now here's our formula, which we know. The first thing I'm going to do is, well, let's find the base area of this. Now we know to find the base area, this is what we're looking for. We're doing 5 times 4, and we should know that 5 times 4 is 20, and it's centimetres squared at this point, because we're just finding the 2D base area. But we want to know the whole volume. So we're going to substitute in the other values that we know. So we've got our third. We've got 20, which is our base area here, and our height is 6, because here it goes from the apex to the base of the shape at a right angle. This time it's inside the pyramid. And if we multiply those 3 values together on our calculator, we get 40. Now this could quite easily be a non-calculated question, because 20 times 6 is 120. And we should know that timesing by a third is the same as dividing by 3, and 120 divided by 3 is 40. Or you could do a third times 6, which is 2. And 2 times 20 is also 40. Please copy down this example in your exercise book. Pause the video as you do this. Right, very good. We're going to have a look at another example together. You're going to copy it down as we go through, or sorry, at the end you'll pause the video and copy it. So again, it's a square-based or triangular-based pyramid. We've got our height outside this time. We know it's the height though because it's in line with the apex, the top of the apex and the base, and if you carry that on down it meets the right angle, and we've already said before that's what's important. So first things first, let's find the base area, which is 4 times 3, and that gets us 12 metres squared this time. Just notice that the units have changed. Right, next thing, we're going to substitute in our values, so a third times 12, which is our base area, and times 5, which is our height. On our calculator it's nice and easy, we get 20 metres cubed. If it's non-calculator, well, you can do a third times 12, because a third of 12 is 4, and 4 times 5 is 20 metres cubed. Please pause the video and copy this example down in your exercise book. Good, well done. What I would like you to have a go at now are these questions. Just be mindful here, we talked about the height being at a right angle to one of the sides, one of the edges, sorry, of the base. So we can see here, and we can see here, the height isn't actually inside the pyramid, it's outside. And just for question 2, my advice would be sketch that pyramid. Right, please pause the video as you work through these questions. If you need to round to 1 decimal place. pause the video. Right, brilliant, let's go through some answers. So we should have 56 centimetres cubed, 168 centimetres cubed, 1040 centimetres cubed, 84 centimetres cubed, and 160 centimetres cubed. And for this one here, if we've drawn it, it says a square base, so we know that the two sides of the base are 9 and 9, which is 81. We know the height's 10, 81 times 10 is 810, and then times by a third, which we know is dividing by 3 equivalent to, you get 270. You might have just shown the calculation, or lots of you, I know from teaching, lots of you, it helps you to draw diagrams to help you out. Please draw the shape for these sorts of questions. Right, here we go, we're looking at some gold criteria for finding the volume. So here we have our compound or our composite solid, because it's not straightforward, it's not just one 3D shape, it's two put together. It's the cube, the cuboid, and it's the pyramid. Now the really important information here is it says the following composite solid is made by joining a cuboid and a square-based pyramid. Now that tells us that these two sides, or these edges, apologies, are the same length. Now that edge here is the same as this one. So if that's 11, so is that, so is that, and so is that. And we're going to look at calculating the entire volume. So let's start with this cuboid here. We know its length times width times height from our chapter 14 work. So let's substitute that in. 11 times 11 times 6. And we get 726 centimetres cubed. Let's now do the pyramid. Well, there's our formula that we're used to. Now, if we do our base area first, we know it's 11 times 11, which gets us 121. So what we're actually doing is this calculation here. Well, the reason we know that the height is 6 is because, look, the height from the apex of the whole shape to the base is 12. If that is 6, remember this is a cuboid, each of these corner edges are 6, and therefore that bit there on its own must be 6. We get 242 centimetres cubed, and then we add those two bold values together to get our total volume. Please pause the video and copy down this example exactly as it is on the slide. Very well done, Year 10. Right, if you could now have a go at these practice questions. Please show you're working out carefully. Please use your calculator though. Round to one decimal place where needed, and please pause the video as you work through the answers. Right, good. So here are answers: 73.3 metres cubed, 45 metres cubed, and 3,250 centimetres cubed. Right, we're going to have a look at two problem-solving questions. What I would like you to do is just focus on question 6. Have a little look at it and think about what you need to do. And this really does link into chapter 16, all to do with compound measure and those triangles that we all practiced using. Please pause the video and have a go at question 6. Right, good. Now the first thing I advise you do is read it carefully. So what is the mass? Now, you know you're finding the mass, you're given the density, so that should trigger, right, this is a mass density volume question. I need to use this compound measure triangle. That's something we should remember from a couple of months ago. So in order to find the mass, you have to do density times volume. Well, you have the density, but you don't have the volume. So let's draw this pyramid that we're told about. It has a square base of side 4 centimetres and a height of 3. Well, there we go, let's sketch it. Now we know to find the volume, it's a third times the base area times the height, okay? And then we times by a third, and we get 16. 16 times 13, which is our density, gets us 208 grams. Please now have a go at question 7. Read it carefully. It says a crystal is in the form of two square-based pyramids. So they're joined here, there and there. They're joined at their bases. The crystal has a mass of 31.5 grams. What is the mass of 1 centimetre cubed of the substance? Now it's not clear. This isn't a mass density volume question. It's more just a sharing question. We need to know that's the total mass, but what is the mass on 1 centimetres cubed? Now this unit here tells me I've got to find the volume of the whole shape. So if you could please do that first. Pause the video as you do this. Right, good. So first things first, we need to find the volume of one of these pyramids. So if it's square base, that's 3 and that's 3. And then the height must be half, so it's 3.5, and then we get 10.5 centimetres cubed. But there are 2 of those pyramids, so it's actually 21. So the total volume is 21. we want to know what the mass is for 1 centimetre cubed. So you do 31.5 divided by 21 and you get 1.5 grams. This is a really higher level thinking question in the foundation tier. It would also be higher tier as well. So it is complicated, but just look carefully at what you actually had to do and it's something we can all access. Right, brilliant. We're now going to look at finding the surface area. This is our silver criteria from today. Pyramid by adding together the areas of all of its faces, and we should know again, going back to that dice analogy, those 6 faces you can touch. Think about a Toblerone tube, all of the faces, the outside parts you can touch. We're going to find that total surface area. So we're going to look at an example together. So the pyramid shown has a square base of 5 centimetres and a slant height of 6. So now this is actually what's important. We're not interested in that perpendicular height with the apex. We want to know the height of one of the faces of the triangle. Okay, so that's where it's changing what we're using. So we're going to work out the total surface area. Well, let's focus on this base first. It's just a square. We know it's 5 times 5 to get 25 centimetres squared. So we've done part of the problem already. We now know that because this is square based, all of these 4 triangles are exactly the same. So let's find the area of one first, and we know to find the area of a triangle it's base times height divided by 2, or half times base times height. So here, let's do 5 times 6 and divide by 2, which gets us 15. That's one of those faces, but there are 4. So we multiply that 15 by 4 and we get 60. We then have to add together the surface area of the base, the square, and the surface area of the 4 triangular faces. Don't add this as well by accident. It's the total of the 4 sides, the 4 faces that are triangles, and the base, and you get 85 centimetres squared. Please pause the video and copy this example down exactly as it is in your exercise book. Good work, well done. Right, here is another example. Please, using your calculator, maybe sketch the diagram in your book, have a go at finding the total surface area. Pause the video as you do this. Good, hopefully you've gone with what we did in the previous example that you should have copied down, and we found the base area first. So we should know it's 12 times 12, which is 144 centimetres squared. Let's find the surface area of one of the triangles. Because it's square base, we know all of those triangles are the same. So it's 12 times 15, and then we divide by 2 and we get 90 centimetres squared. But there are 4 of those triangles. So let's multiply 90 by 4 and we get 360 centimetres cubed. And then we're adding together our 144 centimetres squared and our 360 centimetres squared, which gets us 504 centimetres squared. And it is still squared because it's an area question. Please copy this down if you didn't get it right and pause the video as you do this. Right, good. There are 2 examples here for you to work through, find the surface area, and then a question here where previously, like with volume, sketch this shape, okay? And for this one, you have to show the surface area is 261. You've got to prove that it is. Please pause the video as you have a go at these questions. Brilliant, well done. So for the first one again, we should have 72 centimetres squared, and we should have 172.5 centimetres squared, and hopefully you've drawn the pyramid for question 2 and managed to do the calculation and find that it is in fact 261, or would be rounded to 261. Right, if you feel like you need extra basic practice with finding the surface area of square-based and triangular-based pyramids, so we have one here, you can have a go at these questions. Please pause the video as you do this. Right, brilliant. Here are the answers that you should have. If you haven't done these because you've got the rest of them right early on, you feel confident, don't worry. It's just for people who wanted extra support. Right, we're going to have a go at this quite complex problem-solving question. I would like you to have a go without me first. I will read the question for you, and then I would like you to pause the video and have a go. Pete wants to paint the roof and the sides of the small hut shown in the diagram. He knows that the hut will need 3 coats of paint, and that 1 tin of paint is enough to cover 12 metres squared. How many tins of paint will Pete need? Please pause the video and have a go at this question. Okay, good. You know it's a surface area question. He wants to paint the outside of the building. So let's find the surface area. And if you've done that, you should have 13.7 metres squared. But that's just once round the surface area. Remember in the question it says he wants to do 3 coats of paint. Well, let's times our answer by 3. So we actually have a surface area of 41.1 metres squared to cover. Well, tins of paint cover enough for 12 metres squared. So how many will we need for this? And you can probably tell from looking it's 4, but just to check, if we divide our total surface area by how much paint coverage we get in one tin, we get 3.425, but you know you can't go into B&Q and say please can I have 3.425 of tins of paint. You'd have to round up to 4. If you got this, that's brilliant. That's a real top level 5 question. If you didn't or you struggled with parts of it, don't worry. These are much more complex questions. These are things we'll be able to look at again in the future. Right, what you're going to do now is there's no Hegarty tasks this week for this, and nothing suitable, but there is an online quiz for you to do that has 5 or 6 questions. Use your calculator, have a go. The link is here, but it's also on the straightforward PowerPoint. It's also on the weekly guidance sheet that you get from Mr. Glover on the college website. Have a go, and then your result will ping through to your teacher. Really well done. Look forward to teaching you through cones next year 10.